In this video, we're going to be looking at 7.7, which is called solving right triangles. Now, we have been solving pieces and parts of right triangles using different methods, the Pythagorean theorem, special right triangles, geometric mean, and of course the trigonometric ratios. But now, what does it actually mean to solve a right triangle? Well, it simply means that we are going to find all three sides and all three angles. Now, we can do this if you know either of the following. So, if you know two sides of the right triangle, or if you know one side and one acute angle of the right triangle. Now, what is new for us is that we have never actually found angles in triangles. We have only been finding the sides of a triangle. So, if we have a right triangle, looking like this one, and I know that this, let's say, is 3 and this right here is 5, then what we can actually do is we can now find the angles in there. Now, it's a process that we've never looked at before, but as you can see in the next part of the notes, it's called inverse trigonometric ratios. Now, before we go to that, I need you to recall what an inverse operation in math is. So if I have 2x plus 4 equals 8, I use inverse operations to get x by itself. So then I would do inverse operations again, and then I would finally get x by itself. So the concept is still the same, it's just new notation that you're probably not used to. So we have an inverse tangent, so it says if tangent A equals x. Now notice here's the angle. Basically what we can do to get this angle by itself is that we can do inverse tangent. Now the little -1 is the notation for inverse tangent. Same thing for inverse sine. You can solve for an angle, okay? You have to use inverse sine and inverse cosine. You can solve for this angle, and it's going to be this. So, what is the big picture now? This is the most important thing that I need for you to remember with inverse trigonometric ratios. These will find angles. These will find angles. So that's the big concept that we are now going to explore.